So the next one is virtualization, right? So this is the backbone for cloud computing, right? Only after introducing a technology called virtualization, the idea of having cloud infrastructure is also started to develop, right? So now, what exactly a virtualization is? So virtualization is a technology to have multiple operating system on a single hardware, right? So let me explain you this with a picture. So now I have a PC, right? I have a PC. So this is my PC. So this PC has a CPU. This PC has a hard disk. This PC has a RAM, right? Now what happens is, when I'm installing a OS, when I'm installing OS onto this PC, so this OS, it can be either a Windows OS, or it can be a Linux OS, or it can be a Mac OS, right? Or it can be any other branch of OS, right? So when I install a OS directly onto the hardware, what happens is, this OS is trying to create a relationship between all the internal components of the hardware, right? So this relationship is created using the kernel, of your hardware device, right? So OS first interacts with the kernel, and the kernel interacts with the hardware components. So they are trying to create a relationship. Now what happens is, every file of the OS, or every property of the OS, whenever that is used, they will send a query to the hardware, and only if the hardware accepts, then immediately the query will be processed. So for example, I am trying to open an application. So I have Google Chrome installed in my desktop. So I'm trying to click this Google Chrome. So when I click this Google Chrome, what happens? So this Google Chrome as an application, they go and request the OS. OS in turn requests the kernel, and kernel go and checks for the hardware availability. Only if the CPU and RAM are available, then only the kernel will give an acceptance to the OS, and OS in turn opens the application which I clicked, right? So if the RAM and the CPU is not available, then what may happen? It may take some time for the application to open. It may take some time for the application to open. So that's why when you open multiple applications simultaneously, right? So the system will be slowly responding. The reason is because the kernel is trying to check with the hardware for free space, right? And if the hardware is free for that particular time, then you will be allowed to open the application, or else you will not be able to open that particular application. There may be some lag in opening an application, right? So now what happens in virtualization is, on this kernel what they have done is, they have created a plugin called as VTX or VTD. VTX or VTD. So what is this? This is nothing but a plugin. This is nothing but a plugin which is used to enable virtualization on the kernel. So this is a plugin, or I can say this is a service, or it is a daemon which is running on the kernel, which enables virtualization of that particular hardware, right? So if you want to virtualize a hardware, or if you want to virtualize your PC, you should have enabled either VTX or VTD on your BIOS settings. Hope you know what is BIOS, right? So when you're trying to install the OS in your machine for the first time, right? So there will be a basic input output system. which is controlled by your CMOS battery present in your motherboard, right? BIOS is software of the ROM, right? This is nothing but it is software of ROM, read-only memory, right? So on your BIOS settings, you should enable VTX or VTD. Only after you enable these two services, you can virtualize that particular hardware. So when you virtualize, what happens? Now, your CPU that you have, your hard disk that you have, and your RAM, all these three hardware components is getting virtualized, and multiple OSs can run on the same hardware. So instead of controlled by one single OS, so here what I do is I can have multiple OSs, right? So what happens? So every OS will try to interact with the hardware components. So every OS will try to interact with the hardware components, right? So this OS, we call this as a virtual machine. We call this as a virtual machine. So this is not your original machine that you have. It is a virtual machine, right? So, but you have to understand one thing. So now, for example, so this one is uh, it is a 8-core processor, and again here I have a 100 GB hard disk, right? And I have some 8 GB RAM with me, right? Now, if these are my now specifications of my hardware, now if the first VM or the first OS that you have created occupies 2 cores, right, and 20 GB and 2 GB of RAM, right? So you should specify what exactly every VM should take from the hardware specification, right? So while creating the VM itself, you should tell what will be the CPU that the VM is going to use, or what will be the hard disk space that the VM is going to use, or what will be the RAM space that a VM is going to use, right? So you can create multiple VMs, but you cannot create 5 different VMs which is using 2 GB each, 2 GB of RAM each. Now, what is the maximum capacity? The maximum capacity is only 8 GB of RAM. So you can only create 4 VMs which is using 2 GB of RAM each, right? Because the resources cannot be overutilized. So virtualizing, in the sense, you are allowing different OSs to interact with the same hardware component, but you cannot overcome it, or you cannot overutilize a hardware resource, right? This will not be allowed. So this is what virtualization is all about. Now, this virtualization is of two types. The virtualization is of all of two types. So one is bare metal virtualization. So like as we discussed, like so what happened, like so before virtualization, what happened? So you have multiple hardware components. There was a single operating system. There was a single operating system which controlled all the hardware components on which an application were running. Now what we did, now there is a hardware. On top of the hardware, I have installed a virtualization layer in which all my hardware components are virtualized, right? So I can have multiple operating systems and multiple applications running on the same hardware. So this is what virtualization is, right? So virtualization is the technology and cloud computing is the service, right? So that now, so there are two types of virtualizations that we are using over here, right? So let me like, so I said if you want to virtualize a hardware, if you want to virtualize a hardware, then on your BIOS settings, you should enable VTX or VTD. You should enable these two settings, only then you can virtualize it. So virtualization can be of bare metal. So there are like different terminologies used. We can say bare metal, we can say physical virtualization, or we can say like direct virtualization. So these are different terms used for this particular type. So this is one type of virtualization, and the other type of virtualization is called as hosted virtualization. It's called as hosted virtualization, right? So these are the two different types. So we'll go one by one. So what is bare metal virtualization? In bare metal virtualization, let me take an example where I have, so this is my hardware. So this is a place where my CPU is present, my hard disk is present, my RAM is present, my network interface card is present, right? So this is the hardware. Directly on the top of hardware, I can install virtualization OS. Instead of installing a client or a server OS, we are installing a OS for virtualization, right? And this OS is called as Hypervisor. Hypervisor, right? On top of this hypervisor, I'm creating multiple VMs. I'm creating multiple VMs. So this is VM1, this is VM2, this is VM3, and this is VM4. Directly on top of the hypervisor, I'm creating all these four VMs. Now, what this hypervisor do? This hypervisor is the OS which directly virtualizes the hardware, right? And this hypervisor controls how every VM is going to interact with the hardware that we have on the bottom, right? So this is going to control how VMs are going to interact with the hardware box which is located on the bottom, right? So this is called as bare metal virtualization. Why we use the term bare metal is because we directly install the hypervisor on the hardware, right? Now hosted virtualization is something where I have a hardware. So I have a hardware, so I have CPU, I have hard disk, I have RAM, I have network interface card, right? On top of this hardware, I'm running a client or a server OS. Client or a server OS. So what is client or a server OS? It can be either Windows or Linux or Mac. So I'm installing a client or server OS. On top of this, I'm running a virtualization software. I'm running a virtualization software through which I'm creating multiple VMs. Through which I'm creating multiple VMs. So this is one VM, this is one VM, and this is one VM. So what happens here now? Instead of having the virtualization OS directly on the hardware, here I'm running a like client and server, a base OS. On top of the base OS, I'm installing my virtualization software here. Now what happens, how the communication happens? So this VM will go and request this client and server OS, and this client and server OS, only if they permit, then I can go and interact with the hardware that I have, right? So everything is controlled by the this particular OS in the hosted virtualization form. But in bare metal, the virtualization OS itself directly manages the entire VM network, which is on the top, right? So this is the difference between bare metal virtualization and hosted virtualization. So I'll give you some examples. Like so, for example, if you have heard about VMware Workstation, VMware Workstation, right? That is an example for hosted virtualization. So VMware Fusion, this is an example for hosted virtualization, right? And so you have Microsoft Hyper-V, Microsoft Hyper-V, and in Citrix we have a software called Zen Desktop. Zen Desktop. So these are the examples of hosted virtualization. So for bare metal virtualization, in VMware we have a software called OS called ESXi, which is a bare metal virtualization, and we have KVM. This is a bare metal virtualization, right? Again, Hyper-V can also be used for bare metal virtualization. Even in Citrix, there are various products which can be used for bare metal visualization. So these are the different examples of bare metal virtualization, right? So these are two generic types. So which you say like recommended one, or which has more advantages? So bare metal virtualization has more advantages than that of hosted virtualization. So what is the disadvantage of hosted virtualization? So what happens is, now for example, here I have a, RAM of around like 16 GB, RAM of around 16 GB. Now this is like, it is a Windows 10 OS, right? And this Windows 10 OS has been installed with multiple softwares, right? So now at least this Windows 10, for them to operate smoothly, at least they require around 3 GB of RAM, right? So now what happens, like I totally I have only 16 GB. So totally I have only 16 GB. In 16, 3 GB is occupied by the base OS, right? So I have only 13 GB, right? Which can be used for creating multiple VMs, right? So this is in hosted. But if you take bare metal, so here what happens is, if I have 16 GB, my entire 16 GB can be used for hosting multiple VMs, right? The 3 GB of wastage is not present, or is not required in bare metal visualization, right? So in AWS, bare metal virtualization is used because like it is for having more resources, right? So why does Amazon is going to waste their resources by running a hosted virtualization, right? And the product used here is AWS runs on Citrix. The major platform that is used by AWS is Citrix only, right? So let me go through the slides. So what is a hypervisor? So hypervisor is nothing but it is the virtualization OS which is installed directly on the hardware, which allows multiple other OSs, multiple VMs to connect or to share the available resources. So every VM is created on a hypervisor, right? So this is how the picture is. So I have a physical server where I have CPU, RAM, and hard disk. On top of the physical server, I am running VMware ESXi as a hypervisor. On top of this hypervisor, I'm creating multiple virtual machines. So every virtual machine can have a different OS. So there are two types of virtualization as I discussed. One is bare metal. In bare metal, what happens? A hypervisor is installed directly on the hardware, right? And in hosted, what happens? I have a OS in between. On top of the OS, hypervisor is installed. A virtualization software is installed. On top of this, multiple VMs are created, right? So these are the different types of virtualization. Okay, so any questions with respect to this topics? Mm, thanks, Rick. Anybody else?
Can you hear me?
Ah, yes.
Yeah, so I was asking, so why would people want to use hosted virtualization if it takes up more memory?
Yeah. So, like, see, hosted virtualization is mostly for the. It is good for the user perspective, right? So, for example, like I just want to create a test bed, for me to practice some applications, right? So in those cases, I go for hosted visualization, because what happens is, for example, like every no person or every user cannot go and purchase a server, and they cannot use bare metal visualization in it, and they cannot create multiple VMs and use it, right? So what happens is, for the user perspective, hosted virtualization stands better, right? But if you think for a very large infrastructure, or if you think for a medium infrastructure, then bare metal stands better, right? So a simple, like, see, if you see here on my screen, I have a VMware Fusion installed. Like, VMware Workstation is for Windows, and VMware Fusion is for Mac, right? So here I have just created some three VMs for me to have a test bed. I just want to practice, some by creating VMs, or from by doing some test in my applications. Only in those cases, like, hosted virtualization is used.
Okay.
Other than
And
that,
the other question I had is then, how does, yeah, go ahead.
yeah, you go it, you go it, you started.
No, I was going to ask, how does auto scaling work? If you say you cannot take up more than 8 GB with these four
Mm,
VMs,
mm. See,
how does auto scaling work with
yeah, yeah.
AWS?
Mm. Actually, see, what happens is, the AWS infrastructure. If you take the infrastructure of AWS, right? So now, no, it is not that you have all the instances are storing in, or getting stored in one single server, right? So the infrastructure has multiple servers connected together. There are like n number of servers connected together. So how they are connected? They are connected using a concept called as LUN. Using a concept called as LUN. So LUN, in other terms, we can say it as like local, it is unit manager, right? So they are like, it is a concept which helps you to link multiple hardware together, or in simple terms, I can say it is connected through a concept of RAID, right? I think you know what exactly RAID is, right? RAID stands for redundant array of independent disks, right? So now, so this server may have around 8 cores of CPU, 100 GB of hard disk, and some 16 GB of RAM, right? Again, this server can have 16 cores of CPU, 500 GB of hard disk, and some 8 GB of RAM, right? So likewise, every server on the AWS infrastructure will be different, right? Now, AWS has not installed ESXi individually on every service. So ESXi is not installed individually on every service. So what they have done is they have installed ESXi on the end all the servers together. All the servers together. So when they are installing the ESXi software itself, they will add all the servers together. They will network all the servers together, and then on all these servers, the ESXi is installed. Right now, when you install ESXi on all the servers, the total RAM should be 16 plus 8 plus 16 plus 8. So if this is 16 and if this is 8, right? So this is how the infrastructure looks like. Now, auto scaling is a concept where you are going to select one VM to start with, and you will say if the VM has resources gone up to 80%, then you increase it to another VM. You increase it to another VM which has the same capacity. So for example, if this is 1 GB capacity, right, the other VM will also be having a 1 GB capacity. So now just try to imagine in this way. So you have several racks and racks and racks of servers, right? Hundreds and 200s and 300s of servers having a single operating system connected via a single operating system. So the infrastructure is very huge, right? So there is no doubt in for Amazon to have an extra space for you to auto scale your VM and create a new VM in your infrastructure, right? So it is not, so Amazon is not giving you one dedicated hardware for you to access. So Amazon is giving you the shared hardware for you to access, right? When I say shared hardware, so your application is not running on single hardware unit. Instead, it is running on multiple hardwares. You don't know in which hardware your application is running, right? Even when you choose for dedicated applications, dedicated instances, if you do choose for dedicated hardware, then the space and the no, the size of the hardware is very huge for you to auto scale, right? And all the hardwares are connected via a network, right? So you got the answer, or still you're confused?
No, I'm good. Thank you.
Yeah. Okay. So now, if you don't have any other questions, so we can take a 25-minute break.